Okay, and all the attendees, if possible, to just turn off your video only when you're asking question, and also your mic, the same thing, only when you're asking a question. The better if you raise the hand, then AJ would be able to see and answer. Well, welcome to our SpaceGeekSpeak. It is a Saturday, and hopefully sun shining wherever you are. We have an incredible speaker today with the Lunar Outpost. AJ is representing his company, Lunar Outpost, and Lunar Outpost is an industry leader in robotics for a lunar surface and extreme terrestrial environments, as well as in space resources. Recent selection for the first ever contract for collection and sale of space resources with NASA, creation of oxygen on Mars via MOXIE on board the Perseverance rover, and participation in the AWS Space Accelerator sponsored by Seraphim Capital have cemented Lunar Outpost as a pioneer in new space economy. AJ, it is a pleasure and a privilege to have you with us today.
Well, thank you very much, Svetlana. Happy to be here. Yes, as Svetlana said, my name is AJ Gemmer. I'm the Chief Technology Officer at Lunar Outpost. Myself and my co-founders started the company in 2017 to address what we saw as an emerging market opportunity in commercial space. So at that time, SpaceX was already doing commercial launches, and in 2018, NASA announced the Commercial Lunar Payload System, the CLPS program, with cost-effective, regular, scheduled deliveries to the lunar surface. And we saw that and we said, well, I think the next logical step in this value chain is moving things around on the lunar surface. People will want to get their payloads, instruments, and technology demonstrations wherever they need to go. And so I'll share my screen and start my presentation. All right, here we go. So as Svetlana said, Lunar Outpost is founded to create fully autonomous robotics and software for conquering extreme environments. And so that means the moon and even extreme environments on the moon, such as the South Pole, which is where our first mission is going, as well as extreme environments here on Earth. So as I said, we were founded in 2017. We're headquartered in Golden, Colorado. Since then, we have been granted a number of NASA planetary robotics contracts, as well as US Space Force and AFRL contracts for robust space systems and swarm robotics. Furthermore, we have a line of air quality monitoring sensors that we call Canaries, which were originally developed in partnership with Lockheed Martin on their Lunar Gateway habitat prototype, and then advanced to the US Air Force on their advanced instrumentation contracts. So we do have two fully funded lunar rover missions, 2022, well, now 2023 and 2024, and several more exciting missions in development. Furthermore, we are part of making oxygen on Mars using the MOXIE instrument aboard the Perseverance rover. As I mentioned, we worked on the life support system on board the Gateway prototype at Kennedy Space Center, and our air quality monitors allowed us to help the city and county of Denver to win the National Mayor's Challenge, which was to improve air quality for school children around the Denver area, as well as Sarah Week's Energy Innovation Pioneer Award, which relates to the deployment of our Canary air quality sensors in the oil and gas industry. So we recently put this video together that highlights a number of the projects we have in development, and I hope the audio comes through. Just let me know if you can't hear the audio.
No audio so far.
Okay, I don't know why that doesn't work over Zoom, but here's the number of landers landing rovers of different sizes. This one is our first mission with Nokia. You can tell from the two deployable antennas on top. Actually, I need to turn the music down for myself. There we go. We're also working with Northrop Grumman on their Lunar Terrain Vehicle project. And this is an even larger rover, a 1,000 kilogram rover that we developed as part of a lunar ice mining challenge. So here's our first mission rover deploying its Nokia 4G LTE antennas at the lunar South Pole. LTV in a cargo configuration. So there's the large rover nicknamed Hippo driving down into a permanently shadowed region. This is a cutaway view showing the rocket mining system that we worked on as part of that challenge. So blasting away at the icy content of the permanently shadowed region and collecting the volatiles. Is demonstrating the versatility of the lunar terrain vehicle that we've been working on. And some visions of the future, what a crater-based in situ resource utilization production plant could look like. This is demonstrating a trenching maneuver that we're able to do with our rover. You can just see inside the wheel is a small regolith hopper, so it's picking up a regolith sample and depositing it in the sample collection. Our offices and some of our capabilities in Golden, as well as testing on VIBE and in the Colorado School of Mines Center for Space Resources Lunar Testbed facility. We also do quite a bit of outdoor testing at the Great Sand Dunes National Park in southern Colorado. And this relates to our regolith collection contract, which I'll talk about on a later slide. All right, so apologies that the audio didn't work there, but we'll just keep going through the presentation. There we go. Okay, so I mentioned the Canary air quality monitors. So when we started up in 2017, we knew we wanted to work on advanced robotics and rovers, mobility systems, things of that nature, but we knew that we would need sort of a near-term revenue driver to help the company get started and to continue to grow independent of, say, funding cycles of NASA and proposal wins, that sort of a thing. And so my background was coming from the Laboratory for Atmospheric and Space Physics, LASP, up in Boulder, where I worked on 8 different spaceflight instruments, but all within their dust analysis group. And so using some of those same physics, we developed the Canary air quality sensors. Like I said, initially it was part of the Lockheed Martin Gateway prototype. So we called it the Space Canary. And you can see the monitor there above Jim Bridenstine's head during a tour. Now, Lockheed was not granted the contract to continue developing the Gateway prototype, so we spun it off into the Earth Canary, which originally detected particulate matter and now can do a wide range of other analysis, such as speciated gases, methane detection, source triangulation, things of that nature. And so, like I said, since then, we've deployed it with many municipalities, communities, and individuals, a lot of adoption in the oil and gas and construction industries, as well as research organizations for ground truthing other sensors, particularly airborne or even orbital aerosol sensors. So we're now deployed in over 35 states with the EPA, Colorado Department of Human Health, City and County of Denver, Montrose Environmental as one of our main distributors, as well as Project Canary. We've collected over 35 billion data points with these sensors so far, and the sensors have an uptime of over 99.9%. So it's a lot of back-end data management and database maintenance. And so through this, we've demonstrated successful scaling and commercialization of this line of products. And this gives a view of our dashboard with a little inset on the lower right showing where our canaries are deployed all over the US. We're also in 15 countries besides that. And this map of the Denver area shows a number of our sensors and their current readings. So you can see that out east over by Denver International Airport, we had some sensors with some high readings on this day. But we've had a number of really notable success stories. So I mentioned the Denver Mayor's Challenge for improving air quality for students. So what that was there was an elementary school, and nearby was a highway, then a ball field, then the school itself, and then another ball field on the other side. And the question was, well, if by choosing the placement of playground equipment and timing recesses, could we pick an optimal time of day for the students to go outside and play? And so we set up our Canary monitors both on the playground, which was closer to the highway, as well as the ball field, which was the opposite side of the school from the highway, and tracked pollution, vehicle-borne pollution from those two locations. And what we determined was that by moving the playground equipment to the other side of the school, and by carefully timing recess times to patterns of low traffic, the school children could see an increase of about 38% in their air quality, which was much more drastic than I think anyone expected. Similarly, we did an anti-idling campaign for parents who are dropping their kids off and picking them up. Again, measured baselines, and then put out notifiers in the school newsletter and things like that to immediately turn off your car when you're picking up or dropping off your child. And from that, we saw an 18% increase in air quality. And that was right when students are, really outside right in front of the school. So just with a little bit of insights into the patterns and what's going on with air quality, you can make these informed decisions that really lead to some good benefits to kids. And so, like I said, Denver was one of the winners of the Mayor's Challenge. Success story around Denver was looking at a map like this. We noticed that several of our sensors were spiking high right in central Denver, and using our source triangulation methods, we were able to narrow it down, or we thought, to a single production facility. And when that was investigated, it turns out that that production facility had recently had new air scrubbers installed in their ventilation systems, and they had been installed improperly. And so this production facility was outputting much more pollution than it was supposed to, or that it was expected to. And without high fidelity air quality monitoring around a municipal area like this, something like that might not be caught for months or even years or ever. And so that was, whereas with our canaries, we knew essentially within minutes that something was amiss. So these are ways that, having these monitors deployed all over an area can really help you react quickly to changes or unexpected observations. So I've mentioned the canaries on Earth, also making oxygen on Mars via the MOXIE instrument. So when our first mission lands on the moon next June, we will be a multi-planetary company, which is pretty exciting. So a little bit more about the rovers. Like I said, we saw this as an emerging market niche. My time at LASP informed me that, while there were many research groups with very high TRL, very mature science instruments, slots aboard rovers were highly competitive. The prior model with JPL Mars rovers, say, was a near development timeline and not very many slots for instruments to be manifested aboard a rover like that. And so I kind of came into this with a vision of creating a rover, for every instrument, for every PI, that PI gets to design their traverses and achieve all of their science goals. And so, as I mentioned, we've got this historic wave of CLPS landers coming up yet. And there are a few other rovers planned, but compared to the amount of static landings, there's really little surface mobility available for these upcoming CLPS missions. And so that is the need that Lunar Outpost fills. So our first mission will have Nokia as our primary payload customer. They would like to demonstrate their 4G LTE communication system at the south pole of the moon. So we'll be landing near the Shackleton connecting ridge and carrying one of their two nodes about 2 kilometers away from the lander so that they can test RF propagation between the rover comm system and the lander. We also have our second fully funded mission, which is in partnership with Johns Hopkins Applied Physics Laboratory. So this is kind of more that vision that I described, where we're providing mobility for an instrument suite at a site called Reiner Gamma. That's at about 7 degrees north latitude, so very near equatorial mission. And the purpose study the magnetic swirls on the lunar surface. So these have been observed for hundreds of years as light and dark lanes and spiral swirls. And so this little rover will carry a magnetometer and a multispectral microscope to explore those. And I mentioned some of our projects in the works. So this large rover, 1,000-kilogram rover, is what we affectionately call HIPPO. It houses that rocket mining system. And this addresses a lot of NASA's interest in in-situ resource utilization. So this rover, of course, is still conceptual. We'll need to wait for a lander capable of delivering a 1,000-kilogram rover or larger to the lunar surface. But those are in the works. And so we're happy to be looking forward to some of these future applications. And as I mentioned, working with Northrop Grumman, AVL, and Michelin on the lunar terrain vehicle, which can be either manned or unmanned and autonomous in a cargo configuration. This shows our current rover lineup. So on the left-hand side, you have what we call our M1 map, the Mission 1 Mobile Autonomous Prospecting Platform. So that is the model that will be going to both the South Pole in 2023 and Reiner Gamma in 2024. You can get an idea of the size. So that rover is 12 kilograms with its payload aboard. The Lunar Vertex rover is about 21 kilograms, so a little bit of mass growth there. But they are both single lunar day missions, so very short compared to past Mars missions. We need to be able to react to all of the new data that we'll be getting and take that into account as we move across the lunar surface. However, of course, what we really want to accomplish is longer missions. So we've also been working on advanced thermal control systems that would allow our rovers to survive through one or more lunar nights and eventually operate during the lunar night and down into PSRs, like I mentioned. And so we call that one the cryogenic operation long duration map, the cold map shown in the center there. Of course, there's also interest in larger payloads that won't fit aboard something of the 20-kilogram size. So we also have our heavy lift map in development, and that one ranges anywhere from about 100 kilograms flight mass to 300 kilograms, depending on what sort of payloads and instrumentations we're using there. And then off to the right, sort of peeking out our larger rovers in the conceptual stage. So it's always fun to see renderings and animations, but I find it particularly compelling when you can see some actual hardware under test. So this was our second generation development unit, MAP 2.0. So on the top left, there's night testing at Colorado Sand Dunes National Park. That helped us a lot with our vision and vision-based navigation algorithms, adapting our vision subsystems for both light and dark situations, as well as testing our thermal control system. On the right is the Lunar Testbed Facility at Colorado School of Mines, where we're really testing on very geomechanically accurate simulants, measuring things like seal wear and dust loading on our solar cells, how much dust is lofted and agitated as we drive. Down on the lower left, Great Sand Dunes testing when it was really hot out, again, pushing our thermal control systems to the limits, kind of representative of that equatorial mission. And dusty thermal vacuum. So that's necessary for replicating a lot of the dust interactions and electrostatics. And again, monitoring the effects of dust loading, say, on our multi-layer insulation, our radiator surfaces, and our solar arrays. And then you notice that MAP 3.0, which is the flight model, looks a little bit different. So we changed the front of the rover to bring the camera subsystem interior to the chassis. On the top left there, you can see the Nokia antennas actually on all three images here. So those are in their stowed configuration. And when we drive a little ways away from the lander, we'll deploy them to a vertical configuration so that we have 1 meter high antennas for the Nokia system. And then down in the lower left is just another view of that regolith collection mechanism. This was in response to a NASA call for proposals for collecting and transferring a sample of regolith from a contractor to NASA. And this was interesting because it is an in-place transfer of ownership. We do not need to unload the sample or return it to Earth in any way. So it's really a policy pathfinder demonstration showing that it is possible for a private company to collect lunar resources and hand them off to NASA. So since we already had a rover which was agitating the surface with its wheels, we designed a collection mechanism that used the motion of the wheels to fill a small hopper there inside of the wheel. And this was when we were presented our first payment milestone for that contract. So the only requirements on the regular collection contract were technically feasible and lowest price. Well, we already had a rover going to the South Pole, so it was technically feasible. And so we bid $1 on that contract and were granted it. And the payment milestones were 10% upon passing our mission concept review, which we did successfully earlier this year, another 10% on launch, and 80% on completion of the activity. So our Chief Strategy Officer, Forrest Mine, there is holding our check for 10 cents from NASA for our first payment milestone. To Bill Nelson's right is Justin Cyrus, our CEO, Julian Cyrus over on the left-hand side. So talking about our facilities at Lunar Outpost, we're growing rapidly. In fact, we're already looking for a new and bigger building, but in our current spot, we have a ISO Class 8 clean room where we do all of our flight model assembly, integration, and test. High bay, including a CNC mill, 3D printing, and full machine shop. And as I've mentioned, a lot of testbed testing in the Lunar Testbed Facility on the right-hand side at CSM's Center for Space Resources. And finally, happy to announce that we have expanded internationally. We just recently announced opening Lunar Outpost EU in Luxembourg City, and that is a wholly owned subsidiary focused on developing advanced thermal control technologies. Again, it's important to us to be able to extend our mission lengths into the days, into the months, or even years. And so some of our thermal technologies, which we've been working on, will be advanced by Lunar Outpost EU and applied both to rovers, but also to landers, habitats, and all manner of other lunar surface activities. And so with that, I think I'd like to stop my screen share and open it up for any questions you might have.
Thank you, Ajay. Any questions? Okay, then I'll start. What was the, I guess the most, at the moment, what is the most challenging part of the development rovers?
Well, that's a good question. Obviously, there are the technological challenges, although, in the past 10 years, it's become much more possible for a company like ours to get the hardware we needed. I just had a conversation yesterday about batteries, and say 10 or 15 years ago, if you needed a battery, a spaceflight heritage battery, you had to work with maybe a prime contractor, aerospace contractor, and it would take many years and be very expensive to obtain that battery. But now there are many examples of flight heritage, say CubeSat level batteries, and that's really been a key technology enabler of our rover developments. But I would say the other challenge there is the speed at which we wish to move. So I mentioned, a traditional rover development program would take on the order of 6 to 10 years to complete, whereas it's only been 5 years since we were even founded, and our development timelines for these rovers have been on the order of 2.5 to 3 years from concept design review all the way through flight hardware delivery. And so that is a very fast pace. Some of our suppliers have been struggling to meet that, but I think that really is what is necessary to advance these technologies and to keep up with the pace of the NASA CLPS program and the vision of the CLPS program.
Mike has a question. Mike, do you want to unmute?
Hi, Mike.
Hi. Yes, very interesting presentation. In your rovers, how much is dependent on automated activities and decision making, and how much is dependent on some operations control either on the Earth or in orbit around the moon?
That's a very good question. So I would say that we scale we will scale our autonomy based on where we are in the mission. So for our first mission, right at the beginning, we will have a human in the loop at all times. It will be very hands-on, basically teleoperation. But as we achieve our threshold mission and progress towards our baseline mission, we would like to introduce more and more autonomy. So the next step up from that would be like automated waypoint driving, where an operator manually uploads the waypoints. These could be anywhere from centimeters apart to meters apart. and the rover drives between them and does some basic obstacle avoidance and hazard avoidance between those waypoints. And then, perhaps once we've achieved all of our baseline mission goals and we can sort of stretch our legs and try out some new technologies, we'd like to increase that autonomy level even higher to automated waypoint generation, where the rover has an objective function specified, say, drive in a circle with radius 30 meters or something like that. And the rover actually plots its waypoints and navigates between them and does all of its hazard avoidance there on out. And so and that could all be accomplished within our first mission. So as our missions progress, we'd like to introduce more and more autonomy. Now, granted, the signal latency to the moon is nowhere near as long to Mars. So teleoperation is possible. We do a lot of testing in-house where we have artificially induced delays in our commands, say about 8 seconds or so. And so it's possible to drive with a human operator, but it's certainly more effective if you can take the human out of the loop and leave more of the driving and operations decisions to the autonomy software.
Okay, thank you.
So what are your
Well, I had another
approaches?
question.
Oh, okay, go ahead. Go ahead.
So I was curious on your financing. You got a whole dollar from NASA, and that's pretty good. What are your other sources of revenue?
Yeah, so the Canaries have been a huge revenue driver pretty much from day one. We've been really pleased with just sort of the industry adoption there. I think that was an area that was really ripe for some new innovation. So prior to the Canary deployments around the Denver area, Denver only had 4 air quality monitoring sites, continuous monitoring sites, and a few more temporary ones, but that's just not enough for a metropolitan area the size of Denver. And so I think once we had those demonstrated those benefits that I mentioned early on, it made a very clear case for City and County of Denver and now many other municipal areas, why they need dozens or hundreds of air quality sensors around their cities. And also, due to some relatively recent regulation in the oil and gas industry that imposed a continuous monitoring requirement on well sites in Colorado, every well site now needs to be instrumented. And so we've sold many sensors that are used in a fence line configuration around the site. And again, have found some really interesting data. There was one case where we put up the sensors and while our technicians were still on the pad calibrating them, some of the sensors were reading a really high reading in methane. And so we investigated that and used the source triangulation. And sure enough, there was a cap that had been improperly installed on a pipe and it was venting basically raw methane into the atmosphere. And under the past regulations for monitoring, they would send out a human person with a handheld unit maybe once every 30 days or so. And so, that pipe could have been venting for an entire month. But again, we knew about it within literally minutes of turning on our sensors, and it was able to be corrected. And so I think because we have such a compelling use case there, we've really been able to expand and grow quickly in the air quality space. So that has driven our revenues, as you mentioned, our $1 NASA contract, but our first 2 missions are also fully funded. So Mission 1 was funded through the NASA Tipping Point program. So that was awarded to Nokia, and then Nokia needed to find a mobility vendor, something to get their second communication node far away from the lander. And so they selected us for that. And then the Lunar Vertex mission is funded through the NASA PRISM program. And then finally, happy to announce that we have also completed a venture capital seed round earlier this year. And so we are now a venture-backed startup as well.
Oh, very good. How many employees do you have at this time?
Right now we are at 62 full-time employees.
Wow, very good. Thank you very much.
Yeah.
That's great. I want to get back to the moon, and literally pun intended. And you mentioned about the dark side of the moon, so the full lunar night. And I know there's extreme challenges because of the extreme temperature. What are the approaches to solve that challenge?
Yeah, that was actually one of our first NASA technology development contracts that we were awarded in 2019, so about 2 years after we got started. And so the call for that one was to develop lunar night survival technologies that did not rely on radioisotopes. So of course, for some past moon rovers, they had a radioisotope heating unit or a radiothermal generator, and that's great. Those are certainly the key technologies for operating for a really long time in a very cold environment. But for a startup like ours, it presents regulatory challenges that are just too high of a hurdle for us to clear. And so we worked on a number of different systems that would we have a 3-step approach basically to our lunar night survival technology development. The first is to hibernate through the lunar night. And so to do that, we developed basically software algorithms that look for warmer terrain features like the sunset side of a rock outcropping, and the rover cozies up to that, which both allows us to retain some thermal energy from that rock outcropping, but more importantly, reduces our view factor to deep space while we hibernate through the lunar night to minimize our heat loss. The next step would be to operate through the lunar night so we could continue driving and things of that nature. So there we need to be independent of static terrain features as well as independent of the lander, because right now none of the CLPS landers are advertising more than a single lunar day. And I realize that I didn't answer the second part of your question, which was about communications and orbital assets. So for our first 2 missions, comms will be a bent pipe architecture through the lander. So we are dependent on the lander and need to remain within line of sight of the lander. However, if we want to drive and rove really far distances, we need to be independent of that. And so there are many proposals for orbital lunar communication relays that we could use as well, which would also allow us to operate on the far side of the moon. And then, of course, the final level of lunar night survival or really cold temperature survival would be entering a permanently shadowed region where the rover will never rewarm. It needs to operate while extremely cold. And so of the non-radioisotope technologies that we developed, no one single technology was capable of fully guaranteeing lunar night survival. However, as a system, a combination of several different technologies, each addressing a slightly different challenge, like I said, reducing view factor to the lunar surface, minimizing heat loss, or generating heat and distributing it to our critical subsystems through the lunar night. As a system, each of those was a key part, and together we believe that that will enable the lunar night survival on cold map, as I mentioned.
Cindy has posted a question, and I actually wanted to kind of follow up with the canaries. That it is incredible, and one of those, as pretty much everyone says, that the knowledge is power, and only when you have knowledge and the data, you can make informed decisions, like either finding that cap was not installed correctly, or the scrubbers, air scrubbers, were not properly fine-tuned to the regulations and so on. Majority of us that join the call right now are from Bay Area of Houston, and we've had lately, or in the last few years, various exposures to different chemicals due to either malfunction of the equipment on the refineries, or the incidents in the Houston channel. So the question is, do you know if there's any canaries installed in Houston area?
Yeah, so I just checked that map that I showed, and it looks like we do have some down there. Now, again, a lot of our canaries are distributed through distributors. So Montrose Environmental being, being the largest environmental services provider in the country, I believe they are the ones who are operating the ones in Houston. Now, for the second part of the question, are they making changes based on the reading? I don't have any anecdotes like I do for the Denver area, because we worked so closely with City and County of Denver. But I do believe that we have canaries deployed down there. And if this is an area of interest, we'd be happy to explore what sort of proactive and informed changes could be made there.
Is it how affordable both the initial installation of canaries, and then of course there's a maintenance because of the back end and so on, that for data analysis. What is the model that your company offering it to the public?
Yeah, so the base model Canary, which has particulate matter sensors for PM 2.5, 5, and 10, as well as two additional sensors, which the customer can choose, speciated gas sensors. Base model would be about $100, and a fully instrumented model with a sonic anemometer and perhaps some other temperature, humidity sensors, things like that, would be about $6,000.
Okay, and what about is there some sort of an annual membership, annual maintenance, and or this is a one-time deal?
No, there is annual service contracts. So there are a couple different ways our canaries can communicate. So we have the Canary E, which has power and data over Ethernet. That's particularly good for mounting on, say, a building that already has power and Ethernet services run. However, many of these pad sites that I mentioned do not. So we also have the Canary S, which is solar powered with an onboard battery that can run for 30 days, even if the solar panel is covered in snow or disconnected. And those communicate over cell. And so, we need to pay for the cell service to these canaries as well. And of course, as you said, all of our back-end data analytics and things like that. So there are a number of different levels of sort of plans there. But yes, there is an annual service contract associated with that.
And is it directly with your company, or it's with, as you said, with the Montrose supplier provider?
Typically, it would be with our distributors. So each of our distributors has sort of an industry that they specialize in. And so they are exclusive to those industries. However, if it were a private individual or a research organization, they could work directly with Lunar Outpost.
That's good to know. Thank you. Any other questions? Okay, Mike, go ahead.
Yes, I'm an investor, and I'd like to know if your company is listed on a New York Stock Exchange, and if so, what's the symbol so I can buy some shares?
We are not. We are still private, but again, we are venture backed. So if you'd like to have those conversations, happy to put you in touch with our CEO.
Okay, thank you.
Okay, but I'm digging back on Mike's question. I'm more interested on the municipal exposure, and I will definitely will connect you with a couple of the local contacts within the municipalities surrounding us, because I believe, again, with both the private individuals as well as the municipal, that we need more sensors in testing, because as you mentioned, the Denver area had 4. Well, the whole, I think, at least the Bay Area, or even more than that, the whole Gulf Coast has only 2 sensors that were provided by EPA, and that is absolutely not enough. There's one more mobile unit that can be brought as needed basis. And when we had in Bay Area incident with the barge, then that mobile unit was brought in 3 days later. 3 days later is not fast enough for the population that need to know whether they need to evacuate or not, because it's not good enough to tell the citizens that you shouldn't have been breathing for the last 48 hours. There's no going back.
Absolutely. Yeah, it's been really quite a journey for us as well. We knew that there was an unmet market need there and some interesting things to be found. But still, now that we've embarked on this adventure, we've come up with all kinds of insights that we never expected. So it's always great to find new applications that can, really help people and improve people's quality of life.
Absolutely. And I'm pretty sure that your both the challenges and the improvements on Earth, on the ground, will poured into or result in those improvements and solutions for challenges on the lunar surface. I can't wait to see what you will discover on the dark side of the moon.
Absolutely. Likewise.
Yeah, and also I know that we've met last year in Dubai at IAC. Are you planning? Do you have plans to be at the IAC this year in Paris?
Yes. So Lunar Outpost EU will have a booth in the Luxembourg in the LSA group. So you can go and meet some of our folks. Julian Cyrus, well, Julian and Justin will both be there, along with some of our employees from Luxembourg. Personally, I will not be able to make it this year. My wife and I just welcomed a new baby, and so I will be home helping take care of him.
Congratulations with the new baby. We need to have explorers. So that's that definitely our future in exploration.
Yes, I agree.
Any other questions from the audience? I know that Mike had a hand. Okay, go ahead, Mike.
Yes.
So we really do focus on the air quality, and our sensors aren't readily adaptable to water quality. But I know for a fact that with Montrose Environmental, they offer sort of packages like monitoring or analysis packages. And so I know that they do have some water quality monitoring sensor suites as well that they sort of pair with canaries or other sensors to analyze, get a full spectrum. So the application I know of for that was on landfill sites, basically. So we did the air quality monitoring, and they used other sensors for the effluent from it to really get like a full characterization of the landfill site.
Okay, thank you.
That's good. I'm impressed. Thank you so much for sharing everything that your company does. And again, as I said, I'm looking forward to the future and what we discover both on our side of the moon and the dark side of the moon.
Absolutely. Well, thanks so much for having me today. It was great meeting you all. And if you ever would like to talk more, feel free to reach out. I'm just AJ@lunoroutpost.com.
Thank you, AJ. And have a great day. Have a great week. And again, congratulations with the new baby.
Thank you. All right. Have a great weekend, everyone.
Thanks everyone for joining, and we'll see you next Saturday.